Okay, 7:30. Let's get started. We have about like 70 participants tonight. That's good crowd. And today we are supposed to be done with the processor design. So I hope by now you all guys understand how a processor does its magic. Like you write a software code and how it is get executed onto an hardware platform, like inside a processor. Any questions? Okay, so there was a question about the preset reset function, how it works. Let me try to explain that to you and hope that's satisfactory for everyone. So let's just concentrate on an S bar R bar latch and with a preset reset. So itself, the latch itself would look like this. S bar R bar latch. Like it has the two NAND, S bar R bar, and Q bar. And let's say, so we understand the operation of this element. Now let's say we added an external reset, asynchronous preset reset, NPRST. So preset on negative value, that is means preset on 0 and reset on 0. What we are claiming, your reset and reset, if both are 1 1, is a normal S bar R bar function, right? Now, if one is 0 and other is 1, then it will asynchronously make Q equals 1, thus Q bar equals 0. And if it is 1 0, then it will make the Q equals 0 and thus Q bar equals 1. And this is not permitted. Means one should not use this configuration that like both N reset and N presets are 0. Now let's see how it works. So remember your S bar R bar has certain logic combination, like if it is 0 and 1, it is a set condition, means Q will be 1 at this point. After this point, if it is 1 0, it is a reset condition. This means Q is 0 after this. And 1 1 is a hold condition, means Qt plus 1 equal to Qt, hold condition. And of course, there is a not permitted combination, which is 0 0. Rest condition, not permitted. Not permitted. Now see, like if my N reset and preset with a normal mode, it should have had this, right? And let's say it was being held at a preset condition like this one. But once from these, a value changed to the whole normal S bar R bar latch operation condition, at that point, it will be either of these three, right? So if at that point, 0 and 1 means is a set condition, we know what's going to be the outcome, irrespective of whether we set or reset that latch, it doesn't matter, it will set the value anyway. And we all know if it is a reset condition, no matter what was preset reset did to the output of the circuit, it will be resetted Q to 0. The only thing we need to worry about is if we are on a hold condition, will it basically honor my preset reset values? Like let's say it was presetted, will it honor it? Like it was set the Q to 1, will it honor it? That is the question. So that means, let's say we put the values, hold 1, 1 here, that is under our observation. And let's assume my Q was 0. That means Q1, Q bar was 1. And of course, at that point, this was like normal operation of the preset, normal operation of the S bar R bar latch. So at this point, we can definitely see my output is being held to these two values, Q and Q bar to 0 and 1 respectively. Now from that point, let's say we have moved to, this is 0, and let's keep this guy as it is, 1. What it will do to the Q value, it will basically move this guy logic to 1. And what it will do for this guy, 1, R bar is 1, and reset is 1. So that means it will move this guy to 0, isn't it? And after that point, let's say this was back to 1, 1. At that point, what will happen now? So at that point, this guy is 1. No, sorry. No, not this guy is not 1. This guy is 0. And this guy is 1. So that means it will still hold this thing, right? It's 1 and 0. So we preset the latch, and hold condition is holding it. And it will be applied, the similar logic will be applied into the other way, right? If we assume now somehow, let's say we are now making a reset from here. Let's make a reset to 0. We keep that reset to 1. So what it will make in terms of logic change, 0 will be moved to 1, right? That means here 1 will be fed. That means this guy 1, 1, 1 move to 0. And after that, if we move back, reset to 1, means the normal condition for the latch operation. Now Q bar has the 0 and this guy has a 1, so Q bar has a 0. So it will help the logic, this guy at 1, Q bar at 1, and that will in turn help the logic at Q at 0. So that means if we apply the whole reset during the hold condition will honor it. And that's what is meant by this asynchronous reset preset. Make sense?
Yeah.
Okay. Any other questions?
For the register file in project 2, you said it was like the memory, right? But it has two data inputs.
Two address.
Two address. Yeah.
Two output.
Does it also like? Do you mean it's like memory as in it also holds like its own data as well, and like it also outputs that back out, or?
What was the spec given? Right? Was there anything specific given onto that project? Let me see. Okay. I'm just trying to pull up your project guide and see what is going on there. Okay, so let's see. Yeah, so as a construction, since we are anyway driving the output port of the register file, two of them with a register, and that is not a bidirectional handling. So that part you need to change. That is a difference from the memory. Apart from the size, like memory is a big size and register has 32 storage location only. So if you don't handle anything on the 00 and 11 on the read-write side, it will act as if it is holding the previously read data. So that was a spec. So you need to hold the data.
Okay.
Makes sense so far? Yeah.
Yeah.
Okay. What else?
When we test our like when we run the DaVinci test bench, those files that it outputs, we're supposed to manually open them and check if they match with the golden ones that you gave us.
Yep. Or you may want to do some deep script or anything, whatever scripting you want to do on top of that to make your life easy. But essentially, you need to compare this golden.
Scripting isn't required, right? We can just manually check them.
Yeah, sure. Why not?
Okay, perfect. Thank you.
But yeah, also like don't just rely on those two testing. Use your own testing, own program to test your implementation as much as possible, because I have more tests which I don't share with you guys to test your implementation. So just don't think that if you pass through those two testing and you are good, you may not. Like at least 20% of the cases in previous semesters, I have seen like people just think, okay, that two test passed, okay, I'm good, I'll get 20 out of 20, no, or 200 out of 200. No, it's not the case. You need to make sure all different instruction works for you. Like especially like those two program doesn't include all the instructions. So you need to make sure you write a test bench, write a test program, and make sure your implementation works for any instructions. And one more important thing everyone miss, like most of people miss in the last semesters, I have seen, and though I always announce it, take care of the reset. make sure, like it may be like the case you're running a program, inside that you are basically hit a reset button or send a reset signal, how your processor is going to react on top of that. Let's say, like in a scenario, let's say you're running one program, then hit a reset, then load another program started to run on the same session. Like it's not another very long session. So multiple reset with loading multiple different program, is it actually giving you the correct output? Please test it. Other question. So as I always tell, like basically testing part, creating test bench, test program, work with your study buddies, work with your study group. You can share the test benches and test program, not the core implementation. Why not the core implementation? Because that is the core of your understanding. So unless you do it yourself, you won't actually feel what goes on inside the processor, how it really works. So Control C, Control V won't help you to understand that. So that's why you need to implement the core implementation yourself. Of course, you can help your buddies to debug problem, troubleshoot, like make a strategy to implementation, but write the code yourself, like write the hardware description yourself. As long as test bench goes, test strategies goes, you can share among yourself.
Professor Patra,
Yes, Anjali?
someone wasn't able to like join the Zoom, so they're on the YouTube, but they're asking if you could please explain the multiplication algorithm.
On the multiplication algorithm. Okay. So I don't see anyone on the YouTube now. Maybe they have joined back.
I'm not sure, but they asked in one of our chats, and so I'm just asking you.
Oh, okay.
I think they're on the
Right. Because yeah, I know like some group of people actually comes late and I don't see the waiting room much when I'm talking. So once I notice, I actually let them in. So that's why like I always encourage you to please join upfront before your time, 7:30, to make sure you don't miss session here, okay? Otherwise, you probably will wait for like another 5-10 minutes until I notice there is someone in the waiting room. Okay, multiplication. Multiplication, let me pull up that note. Okay. That should be around lecture 10. Okay, so multiplication wise, it is basically nothing but addition in a for loop, right? Algorithm wise, you are basically product that register you are assigning to 0, and then you are checking the LSB of the multiplier. If it is 0, then don't do anything. Just shift 1 bit right position, 1 bit left position on the multiplicand side, and multiplier you shift by 1 bit in the left position, and then repeat the loop for 32 times. Now, if it is the multiplier LSB is 1, then you basically add the multiplicand value, current multiplicand value, on top of the product. So after that, this thing goes on. At the end, you are going to get the product result from these flow. So what's is there anything specific doubt or anything specific you are looking for? No? Is that clear enough? Let me see if someone is in YouTube.
So does this only work for 32 repetitions?
No, it is in general, right? This is not 32. Like if it is, let's say you are adding up, let's say multiplying 24-bit quantity in a 24-bit system, then your product register has to be 48-bit, and you still run through it.
Okay, so 32nd repetition is just because it's a 32-bit system.
Yeah. Okay. Let's say I'm trying to work with one student. Why that student is not?
The person from watching from YouTube said it's good.
Yeah, but Zoom session is important, so I'm not sure if there is a technical the difficulties in that. Okay, I'll work with that probably. Anyway, so let's take a little bit break here. Maybe okay, maybe too early, or you guys have any question? So I don't have much today.
Can I ask a question about like the state machine?
Yeah, sure. Why not?
So I want to clarify like the clock, what the clock cycle of the state machine looks like. So whenever you enter, so the state machine includes like D flip-flops, right? And each one of those D flip-flops represents a bit that represents like one bit of the state machine of the current state. So in one clock cycle, like those two bits are being outputted, and then the combinatorial circuits like along with the input create the next like two or something like bits going into the flip-flop, and it also creates the combinatorial circuit also creates like the output. So you have this two current bits for the state machine and the input, which create the output and the two next states. So I'm asking like what's the general what do the signals look like for each clock? So for the first, so in one clock cycle you have like the you have two bits, like two bits of the state that are like being inputted are being used to create the output and the two next states. But like when is the output read? So you have the current state with the two bits that represent the state, and that creates the output. So does the output only get read at the end of the cycle? Like you have this one cycle for this state, and at the end of the cycle it output. Yeah.
Okay, I get general sense of your query. Let me try to explain that and see if it fits into your query. Okay. Let me see. Okay, which one was a state machine discussion? Lecture 8, maybe. I think that should be it. Okay. So let's take this example. So see here, we are using 2D flip-flop as my state encoder, right? So combination of these 2 bit will mean some state. So as we did here, like 0, 0 is state A, and 0, 1 state B, 1, 1 state C, and 1, 0 state D. Now, we start with some reset state with a 0, 0. That means it's a state A, right? Now, that state will give some value around your AT plus 1, which is input to the flip-flop A, and BT plus 1, which is input to the B, D flip-flop of B marked as B. These two are basically outcome of the combinational logic between these state variables and the incoming input, inputs. So on the next cycle, this value, so your AT plus 1, BT plus 1, these 2-bit combination is denoting now what is going to be my next state. But that next state will be registered only in the next clock cycle. So this state, let's say, let me see if I can annotate. Where is my notation tool? Oh, here. Okay. Okay. So let's say it started with 0, 0, right? And that gives for some X state, let's say it basically evaluated to be maybe 0, 1. Okay. Now in the next clock cycle, what will happen? Your this will be reflected or registered at the D flip-flop in the next clock cycle, and this will be registered at the next clock cycle. So next clock cycle, you will have a value of 0 and 1. So basically, now your value would be, or let me just erase this guy. Okay, and that becomes 1, and this will remain 0. And let's say that with combining in the next X, give me the 81 as 1, 81 as 1, and let's say this one as 1, and let's say this one also as 0, for example. Okay. So now in the next clock cycle, what will happen? This one will be registered in this D flip-flop A. That means the Q output will be changed from 0 to 1 at that point. 0 to 1 at that point. And the BT will be changed to 0 from 1 at that point. So now my state become 1, 1. Make sense?
Yeah, that part makes sense. Can you talk about the output? So each cycle, the two state bits and the X come together to create the Z. So when is that Z like read by the outside world?
Oh, for the outside world. Yeah, so
like,
basically, that Z should be written by the outside world a little after I think the clock is done. Okay, so maybe by the next fall of the clock, it should read that.
Okay, so so you're saying that like the 2 bits and the X create a Z, and then only after those 2 bits change in the next clock cycle, then that Z is kind of right. Afterwards.
Yeah. In fact, like to make it like a stable circuit, instead of drawing the combinational output out of the state machine directly, we should actually put a register right there, okay, with a clock and everything. Let me see. Draw, let's say, clock. And your output should be drawn out of that register. so that we know when that output changes, anything output changes, each clock it basically registered that value, so that the outside world doesn't need to worry about when this output disappeared due to some logic changes. Okay, so in the real circuitry, I would expect a register out of this from at the output port of this circuit.
Okay, so can you also explain why you're connecting the clock to that register so that it can store the value of Z. So when does it store the value of Z again?
So it is basically at the same whenever there is a change in state, like change in state means let's say change in state like here, like from C to D, right? And then it is going from D to B, like at that point. During that point, it basically also changing the output logic to 1, and we should register that back in the circuit on the output register at that point.
I think I get it. So you're saying that on the next clock cycle, just before the next clock cycle, Z is already established. So when the next clock cycle changes, this register stores that value of Z, so that in the next clock cycle, like it has all it just like sends that Z signal outside, and you have that whole clock cycle to read it.
Right. And I'm assuming at this point the external world is also synchronized with respect to this clock. Whoever is using this value, so the client of this module will be looking at the Z output with the synchronization with respect to the same clock. So that is important basically for the result to be used by the other components.
Oh yeah, that makes sense. Thank you.
Okay. What else? Okay, then how about some pop quiz? Let's see. Let me just first publish it. Just hold on.
Oh, hey, Professor, sorry, I missed it. Did you see Zachary's question in the chat? Or I missed it if you answered it.
Oh, okay. Yeah, we can just come back after the pop quiz. Okay, so let the pop quiz happen. So I have opened the pop quiz. Please go to your canvas, find the pop quiz 5 and hit yes if you are ready to enter the password. Okay, there are 76 ready out of 81. Yeah, Tanushree, I'll give the access code in a minute once everyone is ready. Okay, let's then end this polling. I think most of you, at least one, except one person is ready. Let me see. Quiz password is the same. Yep. Okay, here it go. A few more minutes for everyone. Okay, I think most of you are done with the quiz. Let me just look at the analytics of that. Oh, average score 47% with a high score of 90%, standard deviation of 1.1. We need to do something about this low scoring pop quiz. You guys are not ready, seems like. Hopefully we'll do better on the midterm since I'm sharing.
Hey, Professor?
Yeah.
Could you unmute so we can actually see what we got?
Oh, okay. Just hold on.
Thank you.
Right, where is that? Not moderate. I want a speed grader. Okay. Okay, yeah, I posted the grade. You can see that. Okay, while I'm here, Zachary, I sent you a message just to you. Can you please take a look about your question? Okay, while I'm here, let's talk about the midterm. Midterm is around the corner, 14th of October, and I have one midterm review topic discussion up in this discussion board, which has detailed information about the midterm, and also tonight's announcement will have that same detailed information. So it is on October 14 during your class time. That means 7:30 to 8:45. Let's talk about the timing first. It will be available from 7:20 p.m. So, you know, like this is a quiz style exam means quiz style means that environment, like a lockdown browser, responders monitoring with the webcam. So you probably need like 5 minutes to set up your environment and everything in that lockdown browser. So start from a 7:20, not from 7:30, so that you have some buffer time there. And your exam will automatically be submitted on 8:50 p.m. So if you actually log in late, like maybe 7:45, 8, you will lose your time simply, right? So make sure you have enter start early, then to have that whole 75 minute to you. This is a 75-minute long exam. And then what it includes? It includes from lecture 1 to 11, the module 1 to 5 till date, till today what we have discussed. Is a closed book, closed note, but you can have one A4 size page of cheat sheet. Both sides are allowed. And also I will supply you with the CS147 DV instruction set in case it is needed to answer questions. Like it will be like a link in the exam so that you can click on the link on the responders browser and you should be able to access that document. You can use your own blank scratch paper to solve the problems. You can use calculator. And I have also opened up the scientific calculator on the responders lockdown browser. You can use that as well. There will be essay type questions. I'll come to that. What is the question like breakdown? But you need to have a proper explanation for that. Just coming out with an answer for those essay type questions is not sufficient. You need to have proper explanation, and explanation carries most of the marks, not the final answer. Okay. You have total 75 minutes, and I will be present to the Zoom session as in your regular class Zoom link. You can dial in using your phone if you have any questions. So the one thing you must have, make sure you have the required dial-in information. So go to your Zoom invitation after the email that you got after the registration. That has all the detailed information, like which phone number you can call, like it's an 800 number, and then enter the meeting ID, password, etc., and you will be connected through your phone on the Zoom meeting and ask me the question. So I will make sure I'll available myself during that time if you have any questions or anything to ask me. Questions so far before I go to the exam structure? Okay, exam wise, 35 pop quiz and quiz style question, total 55 points. There is 21 pointer, multiple choice, style 22 pointers, which is like multiple choice plus tiny problem, which probably you can do mental with the mental calculation if you actually studied enough and understood the subject enough. Then you should be able to do mental calculation on those problems. And then 5 3-pointer small problems. These are very simple. You can probably like take a scratch paper and do it within a minute or two, I believe, if you actually understood the whole subject. So there will be this structure, and then 3 problem solving questions that you need to actually come up with an explanation for that. These are essay writing style question, 1 20-point problem, 1 10-point problem, another 15-point problem. So you need to write the answer using that essay style will give you in the Canvas a rich text editor. You can create tables, bold, make boldface, underscore. You can insert mathematical equation and whatnot. So make sure you basically use all the feature of that rich text editor to make your answer look nice, look good, so that when I review, I don't feel that I have to find out what we are trying to do here. Like it has to be very clean and clear explanation of those problems. Solving steps. I will open up tonight one practice midterm, which basically has similar set, like 35 pop quiz style question, 3 problems. This is to give you a taste what is coming in your way, so that you can actually time yourself. Like you do this one practice midterm and time yourself how you need to pace through. But it has only one attempt. It will show you the correct answer, but only once. So that means I recommend you to attempt it after you think you are ready to take the midterm exam. After you are prepared enough to take the midterm exam, take the practice midterm exam, and study the answer only once. It will show you only once. Study the answers there. And then that will give you a test of what is in the midterm coming up. Note, don't take practice midterm quiz, quiz questions will be repeated on the exam time. Like this is sample practice quiz, right? Practice midterm. So do not expect that it will be just like that question. Like in past one semester, I had one practice exam or at least practice problems in the class, and then some other different style problem came in the exam. The couple of students came in to me and said, I practiced this problem, why didn't it come? Come on, I didn't guarantee that it will come. It will just give you some like timing test on your practice. So make sure you understand that practice midterm question may not be repeated on the exam. Question.
Professor, can you
Yes.
explain what it means by it'll show you the correct answers, but only once?
So remember, like okay. So if you, once you are done with the exam, you submit it, then I think it will close the this browser, lockdown browser, and then if you go through to that quiz to look at the grade, it will not be graded for the essay questions though, but it will be graded for the others, and it will show you the answers there. So yeah, frankly speaking, I don't know what will be experienced at your end. I never done it. This once, give the correct answer once after your attempt is done. So you might, one of you might want me to come back and explain. You explain to me what's your experience on that. But that's only my postulation that this is probably the one. Like you close your, you submit your quiz, it will close your lockdown browser. Then you go to the canvas in the normal browser to look at your grade of that practice quiz, and then you can see the answer. Like once you access it, next time you visit there, you won't be able to see it. That's my best guess.
Okay, thank you.
Professor?
Yes.
Do you have any midterms from previous years that we can reference, or?
I won't rely on that because this is the first time online exam is being held, like pure online style exam. So that won't help those problems or any sample papers.
Okay, thank you.
Only this practice midterm will help to kind of tune in. So I would say suggest like practice those problem sets I have given. That has quite a lot of problems, different variation. And also practice those quiz questions and pop quiz questions, those things.
Hi, Professor. Oh,
yes.
Go ahead.
So I don't think there are any like problem sets for like lecture 11, this lecture. Lecture 11 will be on the midterm, right? But like,
yes, lecture one will be on the midterm. So there cannot be a direct problem, like a mathematical problem as such onto those areas. But definitely like on those MCQ and small problems, like, okay, how many bits, how many bytes, etc., who is driving what, etc., that type of question may come. Like today, whatever that pop quiz came up, right? These are about this lecture 11. So those type of question will definitely come. Not the problem, yeah, we cannot, yeah, unless it is a diagram drawing. And unfortunately for me and lucky for you, Canvas editor doesn't provide any diagram drawing feature so far. So diagram drawing is out of question, basically.
Professor?
Yes.
Professor?
Yes.
Just to confirm, you break lecture 11 into modules 5 and 6. Are we just doing the first one?
5 and 6, is it?
Or like I think he split lecture 11.
Yeah, yeah, it's an entire lecture 11. So
Oh, so everything.
Yeah. So it's module 1 to 5, I think, or 6. Yeah, module
like,
is processor design. Yeah. So module.
Okay.
So module 1 to 5. Yeah.
Okay, thank you.
I think what he was saying was that there was like a lecture 11 in module 4, and it was about the sequential ALU.
Right. Yes. That was the first part. I used to take the same sequential ALU as a part of processor design, but this semester I kind of separate them into 2 different modules.
Will there be any Verilog related questions
No.
on the midterm?
I noticed the practice exam has points. Is it graded or is it just to show us what our expected grade?
I have allocated points there, but I am not also sure how the practice quiz come out. What is your experience? I'm not sure. So yeah, after the midterm, maybe one of you wanted me to explain your experience, right? What is your practice midterm experience looks like? So that I can explain it in next semester, student.
I mean, does it count towards our grade?
MCQ should be graded, not the SS style. So I'm not sure it may comes back to me as to grade them, and I'll probably add some dummy values there. I won't be grading the practice midterm anyway.
Okay.
Are we allowed to use a hexadecimal calculator for the exam?
Yeah, sure, why not? So basically it's a 1-pager cheat sheet, and calculator wise you can use anything. That's fine.
Are we allowed to straight up put bits of the notes onto the cheat sheet?
It's up to you. I am not restricting you to put anything on that.
Cool.
Yeah. Just don't, like put something that you cannot even read back. One semester I had this funny incident that, one student had this tiny writing and forgot the glass to, magnify glass to look at that. That was an incident, quite an incident. I hope you won't be needing that much information onto the cheat sheet. Because I hope, like, if you go through the practice exam, you will realize that there's quite a lot of questions, like 35 plus 3, 37 questions in 1 hour, 15 minutes. So if you think you need to actually answer, you need to go through those information on the cheat sheet. Lot of information will slow you down, basically. So tune yourself, your cheat sheet accordingly. Other questions? Okay, all right then. I think we can stop here tonight. And next next Monday, we'll do this one midterm review. You come up with your questions, and also like you basically update this discussion I just showed you with your choice of topic that you want me to discuss with you before the midterm. Then on 14, the next Wednesday, we'll have the midterm.
Professor?
Yes.
We have a quiz this week?
I think so. Yeah. Just go to the last week's announcement. It is there. I hope all of you guys are following that announcement and doing, taking action accordingly.
Okay, thank you.
Yeah, I think there is a quiz this weekend. Yeah. All right. Good night then, everybody, and see you next week.